Hi, and welcome back to AppSecCon 2022. In this session, we've got two great speakers from TripActions. We're going to be talking about shifting security compliance left with DevSecOps tooling. We have Pravath Karanth, who is the Senior Director of Security Assurance, Compliance, and Trust at TripActions. And he is joined by Chris Collette, who is the VP of Productivity and Site Reliability Engineering at TripActions. Great conversation. Two leaders within the same organization talking about how they collaborate to shift left compliance. Let's check it out.
Thanks for the intro, Mark. This is PK, Senior Director, Cybersecurity at TripActions, and I also have Chris Collette with me, who's our VP of SRE and Developer Productivity. Today, we are going to be talking about shifting security and compliance left using DevSecOps tooling. So the idea of this presentation is with the kind of modern wave of kind of DevSecOps, where engineering and product leaders wanting to innovate at a very rapid pace to enable product disruption and rapid growth in hypergrowth companies. We oftentimes notice that security gets left behind. And we oftentimes notice that in a lot of scenarios there is some level of friction between the security tooling and practices and development practices. So today we are going to be talking about some of the best practices around how we can actually shift security to the left of the development cycle to actually enable engineering and product teams to move fast. So that's kind of the premise of this presentation. We are going to be talking, just to kick it off, we'll give the audience a brief introduction and a primer on what DevSecOps is, why is it important, and then we'll talk about some pragmatic strategies and best practices around tooling and process in your CICD pipeline, and then we'll lastly talk about security compliance and how we can shift security compliance to the left in a frictionless manner. So just to kick things off here, what is DevSecOps, right? So when most of you probably know, when Agile emerged nearly 2 decades ago, it did break down some of the silos that the traditional waterfall method had. However, there was still a need to find the right balance between speed of delivery, stability of your applications, and security, which gave rise to DevOps, right? So DevOps then clearly was an improvement over Agile with its focus on teams, on collaboration and prioritizing automation capabilities. Then think of DevSecOps as a premium package over DevOps, right? It keeps automation, delivery, and customer experience as its primary goal, but with a security-first mindset. And it really seeks to shift security to the left of the development lifecycle. And then today we're going to talk about some pragmatic, applications of this concept and how can it be done in a very frictionless manner. Moving on, why DevSecOps? A practitioner's perspective. Here, we want to give you a perspective from a security side and also from an engineering side, right? So in most of the hypergrowth companies, we see that engineering and product leaders want to innovate at a rapid pace in order to keep up, with the hypergrowth businesses. This means hundreds of continuous deployments to keep up with the innovation and feature requests and so on and so forth to disrupt the market. So it is critical to ensure that from a security perspective that these deployments are secure, and there are mechanisms to detect and flag high-risk deployments. For practitioners, it is also important to provide, security assurance to customers, and there are a lot of audit, asks and risks around this as well. So, in order to kind of reduce risk and enable business to innovate and disrupt at a rapid pace. So, in addition to all of this, maintaining security compliance with a least amount of friction, so that the dev teams can continue to innovate, also becomes a challenge. What I mean by this is, rather than having a checkbox approach to compliance, you got to shift compliance to the left so that it is frictionless and kind of invisible for the dev teams, right? So that's what I want to focus on. So moving on to some of the principles of DevSecOps, I think the takeaway from this slide is we need to move away from traditional security models of security being more of kind of like a checkbox function of identifying requirements and transferring the risk to the business, rather actually be hand in hand with your engineering teams and the business to actually identify and collaborate and identify risks in a combined fashion, so that we can make collective decisions in a way that we calibrate the risk to the business and enable our product and engineering organizations to innovate at a rapid scale. So some of the examples for this are rather than having kind of a mandated security checklist and paperwork, have consumable security services with APIs, right? Automation is the key. Having 24/7 proactive monitoring, so that even if we are taking a risk in order to enable the business, but there's enough monitoring around your overall ecosystem to identify any malicious activity and so on and so forth. And lastly, also compliance operations, right? Rather than having a clipboard and checklist kind of approach to this, having continuous compliance operation and continuous compliance monitoring to provide assurance to your customers and your auditors and meet your audit requirements also becomes important. So from a principles perspective.
Thanks, PK. The DevSecOps is the reason why 6 in the middle of DevOps is that security needs to be a part of every part of the pipeline, right? So, and a lot of this, some of this is harder to implement than others. Some of this will have less traction in certain organizations than others, but the key is integrating security into every aspect of the pipeline to deliver code to production. So starting from design, getting an idea of like, what does a secure design look like, and how do we, think about things like rate limiting and DDoS prevention, in our software designs. Then coding, finding bad smells, finding excessive privileges, finding uncaught exceptions, and things like that might be used eventually as an exploit. As well, scanning the open source software that we use every day. That's very powerful and changes our lives as software developers quite a bit. But over time, they may have vulnerabilities that need to be updated. And finally, in the build process, we have our first opportunity after the build process is done and to actually test the application in a dynamic state. So doing that dynamic security testing is a key portion of what we need to do. And then finally, packaging and deployment. What containers do these go to? Is the environment secure that the deployment goes to? And things like that. I mean, these things need to be thought about and have to be part of sort of a continuous function that we execute every day. And then finally, when we operate, we have to continuously scan to see if the vulnerabilities have been introduced or somehow the network topology was changed in a way that makes an attacker able to access our system. And then finally, new vulnerabilities come up all the time. Either discovered by there's library vulnerabilities like Spring recently had a big one, but also bug bounties. Security researchers will probe your site and find issues. And there has to be an effective way of identifying the risk, mitigating the risk, and tracking the risk so that we can drive forward with a more secure application every day. Next slide, please.
All right. So this slide talks about some security and compliance aspects in a typical CI/CD pipeline. So this is a pragmatic and practical examples of some of the testing testing both from a tooling and process perspective that can be injected into your CI/CD pipeline in different stages of development to shift security and compliance to the left and also provide the assurance that is needed to your auditors and customers. So starting on there, this is broken down into different phases. phases: your local dev stage, and then your pull request phase, and then your build stage, and then finally the staging environment and the production environment, right? So in your development environment, it's super critical to encourage your engineers to use tools to test before submitting the pull request. For example, static application security testing, code analysis, container scanning, doing your supply chain checks for your third-party libraries, vulnerable third-party libraries becomes critical. And then once you move into the pull request stage, it's critical to have at least one reviewer, and it's preferred to have two reviewers, and then you can have another layer of SaaS there. Security review of high-risk changes. I mean, if there is using tooling to determine, kind of high-risk requests here, it's a good time to kind of look at it and have a dialogue about these aspects at that point. And of course, policy checks becomes also critical. And then moving on into your build and deploy state, it's important to have your QA tests and your security tests like input validation, your unit and integration testing. And then, of course, logging your test results is super critical to demonstrate evidences to your auditors when the audit comes, right? And then finally, in the staging environment, you can have some smoke tests and load tests to actually gauge the stability of the application. Container scanning could be another piece that can be injected into this stage. And then, of course, pen testing can be also looked into here. And lastly, dynamic application security testing can be done at this stage as well. And then finally, once you move to production environment, it's critical to have your runtime container scans, your network scans, and your integrity checks, and so on and so forth. I mean, this is, again, a sample example, and you can pick and choose based on your environment and the risks in your environment and your risk appetite. You can pick and choose what you want to adopt, but we wanted to give you like a holistic view of how this can happen in a very pragmatic way. And lastly, some of the other requirements from a compliance perspective is quarterly access review of kind of access to all of these tools in the pipeline, having the right segregation of duties, policy controls, etc., so that you can demonstrate governance and compliance to your auditors and customers as well.
All right. So, we've talked about, hopefully you have a good understanding of what DevSecOps is and how to implement in certain parts of your CI/CD cycle. Now let's talk about what's going to make DevSecOps successful. So there's two major categories. One is agility and tooling, and the other is education and process. So the key for really an effective DevSecOps security program is the ability to make changes in your application, right? The more that you can make safe changes to your application, the more updated your libraries are going to be, the less time vulnerabilities are going to be open, and things like that. So, maturing your process is important. Investing in testing is important. Legacy apps, we can't just leave a legacy app out there anymore. It used to be you could just say, oh, well, it's just going to live and eventually it'll die. Every application you have needs to be updated for the purposes of security. So, the lower risk you can make it, the less effort you can make it, the better better off you are, because simply those changes will occur more naturally and you'll be able to keep up with your security backlog. Then finally, well-configured tools that align with policies, right? Too many times I see tools that are implemented and, oh my God, we have 1,400 vulnerabilities. And that 1,400 vulnerabilities is just incomprehensible for most people, right? It's hard to figure out where to begin. So, start with the most critical, and incrementally turn up the settings once you understand the governance process and things like that. And then really, just try to integrate security into every workflow. This should look just like a bug workflow or something like that. You don't want to have a special process for security bugs or security issues, because you want it to be part of the integrated workflow that developers do every day. And then, a couple other things there. It's just solve common problems globally. Golden images, a lot easier to just have somebody stamp out an image, for the organization, rather than having 20 teams figure out how to build compliant images. And then finally, compliance should be a central feature of your tool set. In CI/CD, it's easy to get into a state where compliance is not being enforced, especially around segregation of duties and things like that. And that is absolutely important for audit. You don't want to get in a situation where you're sending a SOX letter to your customers. It's a bad place to be. And finally, education and process, align, realign on the process expectations and standards. Like, here's what we're doing, here's why we're doing it. And the reason why we're doing it is that we say we do this, and we need to demonstrate we do what we say we do. All right. Uniformly enforce standards. There's always like a troll under the bridge, or some sort of person or team that you don't want to interact with because they're difficult in some way, shape, or form. You can't let these people make decisions for the entire organization. You have to make sure that the standards are applied uniformly. Upgrading, again, this is part of code agility. We should be able to change our code anytime, anywhere, and be able to ascertain whether it works or not. So upgrades become more of a default action rather than, a long-running argument about whether a security update or problem applies to them. Assume there'll be exceptions and figure out how to manage them. Uphold the SLOs of the security team itself. Don't be the inaccessible security team, right? If you're holding other teams to SLOs, make sure that in partnership you adhere to your own SLOs. And minimize security friction. So, obviously there are certain changes that should be blocked. There are certain things that need to be immediately remediated. Don't get into the trap of making everything priority 0 just so you see action on it. If you don't have the resources you need, you're not getting responses, you have to align with the organization onto why this is important. And then finally, simplify and create universal truths. You eventually have to prove that you follow your own process, that you do have a secure application, right? And it's a lot easier if you can just say everything's encrypted at rest, as opposed to, some things in one data center are encrypted at rest and others are not, because that starts getting auditors' nerves tingling, and just proving it becomes so much more of a hassle. And communicating to customers and others, it makes it feel like maybe we're hiding something, or it's too difficult to understand, and that creates suspicion and bias. So let's talk about the hard things. So making these security updates non-disruptive. Many apps don't have comprehensive testing. Sometimes code relies on implicit library behavior. For example, Jackson upgrade, it stopped sending nulls explicitly, and that broke some things, right? So the keys to success here are comprehensive testing as much as possible, and or canary deploys. I'm a big fan of canary deploys, particularly when you upgrade containers and things like that, because it allows you to iterate quickly, make those incremental updates, and not have to go searching for 9 different problems because you upgraded, 14 different libraries by major version increment, right? Avoiding container and server bloat. It's easy to just add things to a container or a server, but it increases the attack surface. So try as much as possible to have single purpose containers, or use hardened services like AWS Lambda. Sometimes Lambda, has some downsides, but the fact that you never have to think about updating, is immensely powerful. Tooling traction, we have tons of tools. They all have different focuses. They all overlap in some way. It can be overwhelming. So, start small, continuously align on the purpose of the tools, why people should react, and things like that. Environment parity. Many teams only apply rigorous change management to the production environment. The more that you can define everything as code, both infrastructure and configuration, the more that you can be sure that whatever action you take against a security bug will continue to be true when you push it to production. And then finally, explaining. right? So making it easy to explain what you do. Again, it goes back to universal truths, right? You talk to an auditor or a customer has no idea about your tech stack. The more that you can simplify and create these universal truths, the easier it will be to interact with all parties outside and work closely with your audit team, of course. And finally, evaluating performance. Most teams use some sort of SLO model, SLO, SLA, based on priority and severity. For example, I've been in organizations where a P0 is, immediate. A P1 bug is something like 7 or 14 days. So you should evaluate continuously how long do these vulnerabilities or problems exist, right? So the key is like we want things to flow as much as possible. So don't seek to prevent all vulnerabilities by integrating like blocking or review processes. Let teams do what they need and then catch up with tooling reviews as we move forward. And then minimize the time that the vulnerabilities exist through engineering agility, fast builds, deterministic tests, CICD, golden images, and really focus on guardrails rather than stop signs. We don't want to block teams because ultimately that's always going to create friction. It's ultimately going to go against our goals, which is to push security updates and good security practices across the organization as much as possible. And, probably the easiest way to evaluate your process, the mark of a healthy process is one where the most critical vulnerabilities are handled very quickly. So, example, Log4j or the recent Spring vulnerability. If you can mitigate those sorts of issues in 24 to 48 hours across your stack, that's a sign of a healthy organization with the right priorities. And the other thing is non-critical vulnerabilities are handled predictably, meaning that P2, P3, actually get fixed. Next slide.
All right. So this slide was created with an intention to, provide, all the listeners kind of some of the controls and compliance aspects that need to be accounted for from, kind of security compliance and an audit perspective as you're moving security and compliance to the left of the development lifecycle, right? So some of the critical things that you need to have is your CI/CD architecture documentation, have a mechanism to, kind of retain your logs for at least 12 months so that you can demonstrate period of operating effectiveness of controls for frameworks like SOC 1, SOC 2, etc. Branch protection should be turned on. And then access to deploy changes to production environment should only be restricted to, some teams. There needs to be some kind of segregation of duties overall so that you can demonstrate some governance around the process. A rollback plan should be documented as well, either for deployment or your general methodology, right? And then access to change QA test script should be restricted to a defined set of teams, QA review, pass-fail criteria, and then, of course, your SAST-SCA, IaaS tooling based on kind of what is applicable and your kind of risk appetite for your environment and your tooling stack is critical. Then, of course, all of this should be kind of wrapped up with the governance layer, with the documentation, process, policy, etc., to demonstrate compliance and provide the assurance that your customers are expecting. So, so that is that wraps up our presentation. I hope you enjoyed this and feel free to, kind of ask any questions.